Welcome to Rex. In this video, we'll be learning about how to analyze the correlation between two random continuous variables using Rex. Correlations measure how variables are related. Specifically, correlation coefficients indicate the magnitude and direction of correlation between the two variables and has a range from -1 to 1. The Bivariate correlation menu in Rex computes different types of correlation coefficients with their significance levels. Let's first take a look at our data. The following data was obtained for 111 days in New York. The average ozone concentration measured in parts per billion, the solar radiation levels, and finally the maximum temperature. Let's say we want to measure the correlation between these three variables. In order to run our analysis, we will first select our data, go to Correlate and Bivariate. We will first be using the Variable tab to define our variables of interest. As we can see, the headings in the first row of the Excel datasheet are displayed under All Variables. We can use the arrow buttons to add or remove variables from the option. Let's select all of our variables, ozone, solar radiation, and maximum temperature, as our dependent variables of interest. Next, we go to the Analysis tab. In this tab, we can select the method for estimating the correlation coefficient, as well as the alternative hypothesis. First, we will calculate the Pearson correlation coefficient. Next, we will select a two-sided alternative hypothesis to run a two-tailed test. Finally, we can go to the Output tab. In this tab, we can select the statistics to output in the cross-correlation table. We also can select whether or not to output a scatter plots matrix to visualize the correlation. Today, we will output a scatter plot matrix. Once we are done setting up our analysis, we can click OK. Once the analysis is complete, a window pops up with the results. Let's take a look at our results. The analysis results display the correlation analysis for each pair of variables. The Pearson's correlation coefficient is a measure of linear correlation between two sets of data. We can use this value to determine how strongly two variables are linearly related. In our data, we can see that the average ozone concentration and the maximum daily temperature showed the highest degree of correlation among the three pairs of variables. Next, we can look at our p-values to verify whether the correlation coefficients are statistically significant. The p-value for each term tests the null hypothesis that the coefficient is equal to 0, as in there is no correlation. At a 95% confidence level, a p-value less than 0.05 indicates that you can reject this null hypothesis. Here, we can see that the p-value is less than 0.05 for all variable pairs, indicating that the correlation coefficients are statistically significant. Two different scatterplot matrices are outputted. The first matrix displays the correlation coefficients above the diagonal, and each correlation is represented as an ellipse below the diagonal. The color, the shape, and the orientation depend on the correlation value. The narrower the ellipse, the greater the correlation between the variables. The wider and more round the ellipse, the more the variables are uncorrelated. The second matrix displays the correlation coefficients above the diagonal, and it also displays histograms with density estimation curves in the diagonal. Scatterplots with smoothed regression lines are displayed below the diagonal. Overall, as we have seen in this video, correlation coefficients can be used to measure the extent to which two variables are linearly related. Thank you for watching today's video in Statistical Analysis in Rex Pro. Don't forget to like and subscribe to RexSoft's YouTube channel for more informational videos on statistics, data, and how to use Rex.